This is the model answer video, question 2, sickle cell anemia and malaria. So we did a bit of background on the Help Me video. These are red blood cells, and people who have sickle cell anemia, the hemoglobin tends to go a bit more fibrous, and we get sickle-shaped cells, and these give you, blood clots and so on, and that's quite often fatal for if you are affected by that disease. But those people are largely homozygous. They have got, so these guys who've got sickle cell disease, so you can imagine they might be homozygous for this sickle cell hemoglobin. Normal people are A, and there's a condition, the heterozygous condition, which is HbA, HbS. So we've got one sickle and one normal. And these guys have got what's called sickle cell trait. So their hemoglobin isn't quite as good as normal, but largely their lives are unaffected. We now introduce malaria. So malaria is a parasite, eukaryotic parasite, plasmodium, and it infects bodies, and it gets into red blood cells. That's why it's really difficult to treat, because it gets inside your red blood cells, and antibiotics don't work on it and so on. And it reproduces and then kind of bursts out and infects more cells, and it's a big problem. And malaria kills a lot of children every year, and adults. There's a benefit to having sickle cell trait if you are going to be susceptible to malaria, which is a strange thing. So if you have the trait, when you get infected with malaria, your cells tend to form a sickle shape, a bit like in sickle cell. And it makes these cells more likely to get gobbled up or engulfed by macrophages and white blood cells. So you are less likely to suffer from malaria if you've got sickle cell trait. So there's a bit of background, and we've got some results. And what conclusion can we draw from these? So these are the trait, and these are the normal. So if you look at the normal ones on the right hand side, we can see there's more people infected with malaria than not infected. Whereas if people have got trait, it's the other way around. More people are not infected. So AO3, suggesting conclusions. What conclusion can you draw from these? Well, you are at an advantage, and you just need to put that into words. So sickle cell trait must provide some protection against malaria. So sickle cell trait must provide protection against malaria or infection from plasmodium. Now this survey, how the survey could be modified. Well, they used 150 people to improve the validity. So validity, is it valid? Is it true? So improve the truth or accuracy of the experiment. It's a strange word. Ways you can always improve experiments. Well, if you only did it on 150 people, well, let's do it on more. So increase the sample size. Not like a spell increase. I-N is my dyslexia. Increase the sample size. And then how else could we improve this? Well, we don't know who the patients were. And maybe the normal ones were all female and the sickle cells were all male, or the other way around, or who knows. Well, let's improve the composition of our sample, so account for age and gender and so on. So account, or keep the same, or some other word, and for age, gender, and so on. Part B, here's a nice Hardy Weinberg question. They're giving us the equations. They're giving us they're giving us this equation, aren't they? Are they giving us the other one? No. So lots of people were able to remember the equation. So P plus Q equals 1. P squared plus 2pq plus q squared also equals 1. So we are given 1 in every 625. So 1 in 625, that is, I just need a different colour. 1 in 625. That's what we are given. What we're trying to find out is this one, which is the people that have sickle cell trait, because that is the heterozygous condition. We're not interested in p squared, so if you worked out p squared, we don't care about that. We just want 2pq. So we start off with, we know what q squared is. So q squared is 1 in 625. I'm trying to find my calculator. No, gone. 1 in 625. 1 divided by 625. When you work that out on your calculator, have I got a calculator in here? Calculator. Shouldn't do this live on there. No, I can't find a calculator. There it is. Okay. 1 divided by 625. 0.0016. And so if we know q squared, we can work out what q is. How the hell you do a square root on this, don't know. But fortunately you should be able to do this in your head. Q is 0.04. So Q is the square root of 0.0016 equals 0.04. So if I went 0.04 times by 0.04, that would give me my 0.006. So Q is 0.04, and that's our first mark. And now, if P and Q is 1, and so P is 1 minus whatever that is, 0.04, because they must add up to 1. So 1 minus 0.04 is 0.96. So now we know what P is, and we know what Q is. So if I put these up here, so P is 0.96, Q is 0.04. And so if we know what P and Q is, we can find out what 2PQ is. So we've got 2 of our 4 marks. So this sickle cell trait proportion is 2PQ. So it's 2 times P 0.96 times by Q, which is 0.04. So 2 times by 0.96 times by 0.04. And that gives us 0.0768. This is a proportion of 1. So it's a fraction, but we need per 1,000. So that in theory, that if we had one person, what fraction of them would have it, which is impossible, of course. But if we've got 1,000 people, we need to times it by 1,000 now. So is 2PQ times by 1,000, so 0.0768 times by 1,000. So times by 1,000 is 76.8 or 77. So 76.8, or you could say 77, you'd round it up to a whole person, which is fine. So those are your 4 marks there. Lots of practice questions available for those. Bring a proper calculator and don't use your phone like an idiot, like me. And we've got 5 marks. 5 marks. Hardy Weinberg says the allele frequencies remain the same in the absence of natural selection. But this is what we're going to talk about now, natural selection. Predict, what jobs have we got to do? Predict something. So predict how the people with sickle cell trait would have changed in USA and Africa. So up, down, all stay the same. And then our second job, explain the basis for your prediction. Okay. So you can do this either way around. I'm going to start off with Africa. Then, due to what we explained over here, then sickle cell trait is going up. So what information have we got here? In the USA, we've got fewer than 2,000, and in Africa we've got 150 million. So it's telling us more malaria in Africa. So in Africa, more malaria. So proportion with sickle cell trait would increase. So proportion with trait would increase. And we need to, this is a bit that people didn't really do, explain the basis for your prediction. So people with the sickle cell have a selective advantage, so less likely to be killed by malaria. People with the sickle cell, back to where we were here, they've got a selective advantage because they're less likely to be infected. So people with the trait less likely to be infected with malaria. So selective advantage. And so if they're at a selective advantage, we're just going into our natural selection theory now. So they will survive. So selective advantage, more likely to survive. Reproduce and pass on the sickle allele. That sickle allele there. To the next generation. And in the USA, very few cases of malaria. So who fares the best? The people with normal hemoglobin or the people with trait hemoglobin? Well, it's the normal, because the people with trait might get ill with sickle cell or be at some disadvantage. So in the USA, few cases of malaria. So less malaria. So no selective advantage. So our sickle trait is a disadvantage. So selected against. So people without the trait are more likely to survive, reproduce, pass on the normal alleles to the next generation. So 5 marks in there. 1 for the basic with the proportions, and then the rest of them is explaining.